My name is Bailey McNitt, and I am a senior at the Severn School. Over the past year, I have been working on my Fellows project involving micropollution in the Chesapeake Bay. Though I had to endure some early bumps in the road, I am so excited to have finally finished with a project that combines my love for marine biology, citizen science, and global health initiatives. I first became interested in micropollution while working a charter with my aunt in the San Blas Islands of Panama in 2017. We were exploring a small coral island when I discovered that the exposed reef was filled with plastics, primarily styrofoam and bottles, that had been washed into the hollowed interior of this spot. I discovered a similar scenario on several other islands, and it was at this point that I realized the impact of micropollution spread far beyond the Pacific garbage patch. It was an international health crisis in the making. When I returned home, I continued to research micropollution, keeping in contact with my aunt who had begun to run studies off of her boat to determine how widespread this issue was in the archipelago. I was unsure how I could further proceed without the resources, opportunity, or experience to run an experiment, and so microplastics drifted to the back of my mind until the end of my junior year. Coming into the Fellows program, I had high hopes and big ideas for how I could raise awareness about microplastics. My original proposal included numerous testing sites ranging from Panama to the Florida Keys up to the Chesapeake Bay, but I quickly realized this was far too ambitious for a senior year that was sure to be filled with college apps and other responsibilities. Slowly, the project took on its current form, as I found a home making vlog-style videos, something I was already comfortable doing, and uploading them to YouTube. Last summer, I put roughly 50 hours into building a prototype for my trawl, modifying it so that I collect valid samples, and then building a larger version of that same trawl, which was similar to the one my aunt was using in Panama to collect her own research. I had limited experience with woodworking, and by limited, I mean I had helped build a pinewood derby car for one of my brother's Cub Scout troops a couple times, and had to learn to use the tools, as well as rework part of the design to better fit my net. When all was said and done, I had constructed a low-tech aquatic debris instrument, or lady trawl, using oak wood, PVC pipes, and a plankton net. I nicknamed my trawl True, and we set off to collect samples. This is True. Though I did modify the design slightly to fit my time and resource constraints, the basic plans for True came from the Civic Laboratory, which designed the lady trawl in 2016. She was designed to be a more cost-effective model for citizen science than the larger Manta trawl, costing 85% less than her cousin at only $300. This lower cost does come with certain technical sacrifices, but the detachable cod end at the base of the net makes it easy to collect samples and transfer them directly to the lab. Unlike the Manta trawl, which requires complicated trawling systems and technical expertise, True can trawl off the side of a boat using nothing more than a 2x4 nylon line and a boat hook. She is relatively low maintenance and a valuable tool for students who want to learn more about the watersheds they love. My next challenge when using True was to collect qualitative data that I could analyze. I had a series of problems with my trawling, ranging from needing to adjust the PVC so that the trawl would skim, not dive, to summer squalls that forced us to change trawl dates. I was finally able to collect a sample. It was lost when my dad accidentally emptied the wrong bucket back into the water, and the amount of sample I was able to salvage was not sufficient to make valid claims. However, this sample did allow me to begin to understand what kind of microplastics were present in that trawling location on that specific date. However, no further claims were made from that first sample. I slowly refined my efforts and found it easier to trawl, eventually teaching myself to analyze the microplastics and place them into 5 distinct categories: fragments, fibers, foam, nurdles, and microbeads. I found both microbeads and fibers in my samples, confirming research I had found earlier in the summer regarding microplastics in the Chesapeake. I began to reach out to experts in the field and actually found a mentor in Miss Deborah Magadini, a New York high school science teacher who works closely with Columbia's Lamont Doherty Earth Observatory to study microplastics in the waterways of New York City, specifically in the Hudson River. We designed an experiment that would allow me to bring Chesapeake oysters up to her labs at Columbia and study the impact of these plastics in the digestive tracts of marine organisms. Unfortunately, COVID-19 had other plans for my project. My experiment in New York was canceled, and I could not access the boat needed to continue to trawl this spring. So I pivoted, again. Embracing a more citizen science and activism approach, I began to target my videos at what products in our homes contribute to micropollution, and how we can change our lifestyles to slow the millions of tons of plastic flowing into our watersheds and oceans each year. I also did a beach cleanup to see if I could find one of these sources of plastics, and also to show that the plastic we leave on local trails does not stay there. You're more than welcome to check out these videos on my YouTube channel. I would like to thank the generous Eni family for helping me explore a topic that is so important to me, and also thank my mentors, Miss Carrington and Mr. Witzel, for being so patient as my project changed and then changed again over the past year. Finally, I would like to say thank you to Miss Carsley, whose dedication to the success of each fellow was invaluable. Thank you so much for your support, Miss Carsley. This has been an incredible experience, and I'm so grateful to have been a part of this program. Micropollution is not a singular issue confined by the bounds of geography or even to a single people. Instead, it is a global challenge and will cause a health crisis if something is not done to prevent these plastics from binding to toxic chemicals and entering our food chain. I encourage you to reach out and learn more about this environmental crisis and do your part to help keep our watersheds clean and healthy. Thanks so much, and I'm so excited to see what next year's fellows do.